Hello, do you hear me? If you uh ch- if you hear me, can you just say and type yes in the chat room? Oh, thank you. Thanks so much. Yeah, I have very complicated setup. So sometimes the transition is not that smooth. Great. Okay, so I'll be back in a few minutes. Okay. Can anybody just type anything? You just confirm that you could hear me. Just say yes or I can hear you. Okay, thank you. Thanks so much. So, wow, so many yes. Thank you. Yeah, let me just turn off this camera because I'm gonna see my the iPad and switch to the slide that we've been working on. Okay, good. Um, so far, you guys did great job, and following my lecture is, well, usually not kind of easygoing because I care some fundamentals, but yeah, you're learning rate and your attitude is so far the one of the best, and keep it. Yeah, your life success sometimes that your attitude is quite important. All right, so I'm gonna ask you a couple of questions, and you could just type it. Yeah. My students are quite shy and which chapter are we in? Oh, let me just trans save. Great, chapter 7. Thanks. Uh, Let me just start the hide caption, few full captions, and I. Okay, good, good. Yeah, chapter 7. Thank you so much. Well, sometimes when I was a student, then I didn't care. Sometimes I didn't know which chapter are we in. Uh, but again, whenever you study any subject, the chapter title and subsection title, those quite like trivial seemingly, but it's important. So here, number one, sample variable from population of this one. So this is, we have a point statistics. Point means you have one variable. That's why you call it point. Um, you you remember that you studied 271, the engineering dynamics. That is very, very close to the physics, mechanics, and dynamics. Um, then we learn like particle and rigid body, right? So in CEE 271, we have particle and rigid body. How are they different? Well, particle has mass, rigid body also has mass. Particle has position, velocity, rigid body also has position and velocity. But the big difference is when we say particle, well, it is point mass. In other words, we neglect their size. Okay. So particle means like volumeless rigid body or point mass, something like that, that, well, only position is important, although mass is included, but their size is really, doesn't really matter. We count how many. Statistics is similar. So we have this point statistics with one variable. Okay. In
Sir,
that case,
it's not showing the screen.
I
The
didn't
screen's
ch
not.
I
Yeah,
didn't change
that's.
the screen.
Oh no.
Yeah, yeah, yeah. I just load here, yeah. Circle. Yeah.
Yeah, it's not showing.
Huh?
It's not sharing.
You don't
Like if you're. No.
see this. Why? Why I can see my screen?
Yeah, I
So
don't see like the stuff. It's just like all the names.
what do you read right now?
Just like everyone's names. Like I can't see like what you're presenting like from your
Oh,
screen.
uh, let me redo it. Okay. Stop share. What about now? You still don't see?
Still the same for me.
Let me. Okay, just a moment. Give me 1 second. So I stopped sharing and share screen or podcast. Now, still same.
I don't know. I don't want to look at.
Yeah, it's still the same for me.
What do I do? Just a moment, then I need to share something else. Give me 1 minute. This, yeah, I gotta share my PDF in this computer.
I'm sitting here.
Not okay. So then I'll share. How about now?
I can see it now.
Okay, good. But this is not what I wanted. Just 1 second. I chapter 7. Okay, you see the chapter 7, the first slide?
Yeah.
Okay, good. Yeah, okay, thank you. Whew. So we gotta go page 25. Okay. Let me quickly explain it. 25. Then we gonna solve some problem. Okay, 25. Yeah. So this one was a soda bottle that we discussed before, and that is actually the proportion. So here we had two different types. The proportion, this slide is just a moment. Okay, here we go. Proportion type. Okay, so in previous case that if you have one variable, not comparing two different cases, that in the case we have a point statistics and this one is proportion statistics. So let's see, soda bottle of a previous example claims 5%. That is given as, yeah, this one is 5% is actually probability of success in a way that we define it is a success. So technically, not everything that we kind of think that is not desired, it still could be success depending on how we design. And the quality control technician randomly samples 200 cans of soda. So here we actually have very important sentence. So, I mean, to be good at the statistics and probability, then the language used in statistics and probability are a little bit different. But it's very specific way. So we gotta be very somehow be familiar with it. So here it says a quality control technician randomly samples 200 soda cans. So 200 soda can. So this one, soda cans, that one is considered as equals to sample size. Okay. So we have 200 soda cans. Are they identical soda cans? Question. There's 200 soda cans. Are they identical? Uh, I want to look at the chatting window just one. Yeah, chat. Okay. So again, let me ask you a question again. We have 200 soda cans. That's what the problem says. Are they identical? Yes or no? You could type yes or no. Are these 200 soda cans identical or different? I am waiting your response. Different? Are you sure? Yes, they are different. Um, so another thing is that you guys you don't change your answer based on my reaction. Okay, they are different. If they are same, we don't need any statistics, right? Yeah, so we have 200 different soda cans. Okay. Another thing, so this is n sample size. So I should say variable n indicates sample size. Other one is how many times did we or he, how many times did he sample 200 cans? How many times? How many times did this technician sampled 200 cans of soda? Yeah, you can write your answer in chatting. This is important one, so I just want to get your feedback. I have one answer. Anybody else? Yes, once. So in this case, I would like to say K equals to 1, just for simplicity. Okay, so we're just gonna say because sampling action is just once, therefore we're gonna say this in case K equals to 1. How many different soda cans? That is sample size, so N equals to 200. Okay, good. So N is 200 in here. That's what given. And then P, the probability that we actually calculate as 0.05. So here we have p-value 0.05. That's what we calculated. How do we get 0.05 here? So this 0.05 equals to tabulator equals to here we have 5% and then oh yeah here now we don't calculate it so it's given as a 5%. Okay, let me just throw the other line 5%. Okay, and Q is Q equals to 1 minus P. So value of Q is 0.95. So 5% of whichever event, we define it as success. And then Q is the other one. Probability of failure is 95%. Okay. Now the next thing is this slide calculate N times P. So N is 200, P is 0.05 and the product is 10. And obviously, n times q, that is, well, how many times? Yeah, it's much higher. So 190. And how do you know that your 190 is correct answer? Hmm? Is there any other way you could calculate value of NP? How do you know this 190 is correct? Let's change the background. Any idea? Transparency. Because NQ and NP adds up to 200. Great. Yeah, so, oops. So PN times Q, that is actually you have two ways to calculate. One is just like this, n times q, or it is equal to 200 minus 10. Yeah. So again, the reason I just gonna keep telling you different way of thinking and checking, where statistics, topic is a very, very easy to make a mistake. Number one, numbers are kind of different from what we are doing, and then concept is confusing. So I actually tell you that kind of different ways of checking your answer. So if you develop this kind of habit, then it will be very, very helpful later when you do a real world project once you hired. Okay, so question is, what is the probability that more than 10% of cans are underfilled? So, well, underfilled is actually the event of success. Okay, so P bar or P hat, that is actually the variable kind of corresponding to the other X. In previous examples. So here, this 10%, let me just use arrow. Here we have 0.1, that is actually from this 10%. And then the 5%, 0.05, that is from this one, 0.05. Then we know that the standard deviation of this proportion is square root of n times p times divided by n. So therefore, here the denominator is sigma, that equals to square root of p times q divided by n. So we have a p-value of 0.05, q-value 0.95 divided by the 200. And once you calculated your p-value, the probability, that would be 0.006. Very, very rare. Yeah. So no matter what, we are using or dealing with the point statistics or proportion statistics like this, then, well, at the end, all the processes are converging to calculating the z-value and try to find out the statistical probability, meaning that the difference between two cumulative density functions. So here the general way is what we usually do, probability, which is a cumulative density function, whether it is a normal distribution or others. Our job is in chapter 7 is we have Z1 starting point or Z low value. Let's just use Z1 low value, and then Z kind of variable. So Z, what is a probability that your Z value is greater than Z1 and less than Z2? That is actually the general mathematical the question, and that could be answered by we calculate P, yeah, P of Z2. So this P of Z2 means probability that the value of probability that the value is equal to or less than Z2, and minus probability that the Z value is less than or equal to Z1. So this equation that I just made, and that is like almost everything in chapter 7. So most likely our job or your task is in every problem to calculate the Z1 and Z2 here and calculate the difference. Sometimes we actually have case like Z1 is negative infinity, then yeah, then probability to get negative infinity, that is 0. So one of the P Z2 and Z1 could be 0 or 1, but in general, and this is the case. Okay, so next slide. Statistical process control. This one is nothing but the case that we calculate the mean and we calculate the standard deviation in previous case. But in this chapter, the standard deviation is somehow, how do I say, generalized. So here mean is same, but in previous case, standard deviation, it goes to sample error. So it is acronym is SE, the sample error, or in a simple kind of term, that simple notation, just S. SC and S, those are there we go. Those are sample error. Conceptually, it is identical to the standard deviation, but their calculation method is slightly different. So the concept of this process control is, well, we have X value, and then we're going to calculate the mean plus 3 times of SC. Okay, and we're just going to calculate the right-hand side value. This is maximum, upper limit. And then the good product should be in the range. The minimum is mean value mu minus 3 times of SC. So we try to check whether our sampled value X is within this range or not. So if X is within this range, then we say it is the control, in control, as we see in here. So if this condition is met, then we can say it is in control. If not, then it says the out of control. Yeah. So out of control means this I've been using this. Okay, so out of control means, let me just rewrite it. Means that your measured value of X is greater than, maybe can say M plus 3 SC. Your X is greater than that, or your X is less than M minus 3 SC. So in that case, X value is unacceptable because it is either too large or too small. Okay, so, well, soda cans and bottles, well, may not have this. However, well, yeah, if you have like a 12 fluid ounce soda, then you actually have like 6 ounce, then you cannot sell it due to the volume kind of confinement. Then you couldn't put too much soda, but if it is too large, that the top of the soda bottles, which top portion, which must be filled with air, that portion is too small, and when the temperature goes up and down, and your soda can, the mechanical stability wouldn't be guaranteed. So in statistical process control, that we have mean value and we have a sample error, quite close to conceptually the standard deviation. And if the process is in control, then all the measured sample should be within this range. Okay. So here, sigma divided by n, that is actually the sample error. So we have, instead of sigma, then we say this is the case. Sigma divided by n, and note that this n is sample size. Today we're gonna solve a couple of problems, but one last problem is a little bit confusing, and I intentionally include that to confuse you. And then to make sure which value we should use. Okay, let's see the next. So here, again, we have sampling. So we have samples of size n. So n is sample size. Okay, so previous case that the technician uh, collected like 200 soda cans once. So in this case, like n equals to 200 soda cans. Good, that's what n value is. And here we have something new to generalize. K equals 1 time or once. That was the value of n and k in the previous example of soda can. Then we have mu value, the mean and the standard deviation of what? It is of population. So then how do we get this population? Well, that is, how do I make? Yeah, all population. Because previously there's like hundreds of thousands of measurement that we can treat them as the population. So in factory that, well, you could actually measure how much a percentage is like product that you couldn't sell or defect or deficient. You measure this and every day, and that could be considered as a sample to test today's production. However, it could be used as the part of the population. So your population size increases as you produce more and more, but today's measurement would be used as a sample. So today's sample equals to the tomorrow's population, part of the population. So you actually, the measurement having the n is the size of sample, and k value, that is, I would like to say, is the frequency, how frequent you kind of measure it. Frequency, good. So k is the frequency number and n is the sample size number. So mean mu, that is actually you have x bar bar and double bar. Okay. So you see you have two bars on top. That means your average is over the k as well as over the n. Okay, so you actually make a sum. So here you have two bars. That means sum from, let's say, sum I equals to 1 to n, or n. And also you have sum j equals 1 to k. Yeah, so let's say you have a 200 soda cans, and just example, if you did it 3 times, then you actually have 600 soda cans, and then your measurement mu, that is based on the 600 soda bottles. Okay, that is what you say n times k. So that one would be equals to 200 times 3. In this example, is 600. So you use the 600 soda can, whatever you measure, and you calculate the mean, that is x double bar in here, and also the standard deviation. Yeah, standard deviation, that is actually using the 600 kind of values. The standard deviation sigma is estimated by S. We use S or small s or big SE. Those are the same, and that is representing the sigma. Okay, the standard deviation of NK measurement, blah blah blah. So N is sample size and K is frequency. That's something that you need to remember. Yeah, N is sample size. It is very, very confusing. Frequency could be, I mean, it looks likely sample size, and sometimes sample size is looking like frequency. But when you have different object of same kind, that is usually the sample size n. Okay, we'll see. So here, you have two lines, lower central line and then the upper central line. So quite simple, -3 and is in here. And then you have +3, okay? And then you calculate the grand mean. So it's said like, let me just use in this way, bar and bar, x, that is grand mean is over sample and frequency. Okay, that is grand mean. And there's also S. S is the grand standard deviation using how many like measurement? N times K measurement. Yes, same as mean. So let's say you have a 200 bottles and you did this like 3 times. In that case, n equals to 200, k equals 3. So this S of standard deviation, well, sample error, technically, S or let's say SE, that is a standard deviation of 600 soda can weight. And this X bar is also 600 soda can. Okay. And then you calculate X bar in here, 2 bars on top, same as like two triangular brackets. And S value is the grand standard deviation, and you divide by N, okay, and then you multiply 3. So plus value will give you upper limit, and the lower value will give you the lower limit. In this case, again, n is number of samples, not the number of, frequency number. Okay. So for population, it's pretty much the same as we did before, that x minus n becomes p hat, and then the standard deviation in this case equals to pq. So if you make an average, that and compared to previous case, you have a sigma equals the square root of PQ. And then you divide the sigma by square root of n. So if you look at the previous case, then your S here, your S, that is corresponding to square root of P times Q. So your S is corresponding to square root of PQ, not simply PQ, but square root of PQ. Okay. So these equations are kind of just take and use. Calculating P bar is same. So K is the frequency, okay? Then N is the sample size. So technically this equation gives you whatever I just said. You just calculate the mean of everything. P values, same. So here, some confusing part is sometimes this P bar is non-known. So we need to assume, but obviously whichever the product to P bar is 1 minus P, which is like Q bar, it'll be clear when you solve the problem. So key things like that. So let's just calculate, do some practice. Yeah. So this slide is uploaded. And then the first problem is 23. So this is actually the point statistics. We are not comparing P and Q or proportion, but we have very definite quantity. That is the number of days. Number of days that battery survives. So I'm gonna give you like 3 minutes and try to solve up to problem A. Okay. In the meantime, I'll try to fix this iPad. I mean the Zoom connection. Yeah, I can see this on my iPad, but reverse broadcasting is not possible. I don't know why. Okay, so you are supposed to solve this problem up to the number, the first problem, first subproblem A. Probability, the average is between 1100 and 1110. So since this the file is on the Google Classroom, let me just stop sharing. Okay, good. So everybody start, right? Yeah, this file is in the Google Classroom. So I'll start the reviewing it in 2 or 3 minutes. Share screen. I think I found the problem. Oh, here we go. Jesus Christ. Do you see the iPad now?
Yes.
Oh, thank you. Yeah, I misconfigured it. I just option was like screen shared only to the host. Okay, yeah, we're gonna solve this problem. Good, good. Thank you. So just again, the most problem is like calculating z-score. Okay, good. Anybody actually calculate the answer for A? Yeah, let me know if you actually calculated it. Okay, good. So let's start. I think I'm getting old, and I was like technical geek, but now I'm not. So a certain type of automobile battery, yeah, this battery is kind of different, should be, um, is known to last an average of 1110, so 1110 days. So you could say that mu value, whatever it is, equals 1110 days. Yeah, we don't need unit most likely, but well, unit always gives us, I mean, help us to figure out what it is. Standard deviation. So let me just standard deviation. What is standard deviation in this case? Chatting. Good. Yeah, it is 80 written as here. So this problem is very kind. It's that standard deviation. It is actually 80. 80. Okay. Yeah, sometimes people use this one as 0 uh, to clearly distinguish with alphabet O. Let's just do it. Find the following probabilities for the average length of life, blah, blah, blah. So this is given. And then the case A, our job is to calculate probability, let's say X, that is greater than 1100, less than 1110. Correct? Okay, so let's say this is X1 and this is X2. Now we're gonna convert this X having the dimension of day into Z. So Z1 equals to, I hope you remember, Z1 equals to X1 minus mu divided by, sigma. So of two values are same. The same values are mu and standard deviation. So if you plug in x11100 minus mu value is no, oh yeah, 1100. Yeah, the mu is 1110. Yeah, confusing. And standard deviation is 80. Anybody calculate this value? Two, three. However, our case, we actually need to use the other one. That is, this one should be divided by square root of n. Okay. So if I calculate sigma divided by square root of n first, because that is constant, which is 80 divided by varies, number of values. So 400, that is actually sample size, 400. So 80 divided by square root of 400, that is 20, 20, 20, and then it is 4. Okay, so this value is not 80, but 4. Okay. Um, so your numerator is actually negative, which is negative 10, and then you divide it by 4.0. So answer is Z1 is negative 2.5. Okay. Then your Z2, the upper limit, that is nothing but x2 minus mu divided by sigma divided by square root of n. So we know the mu is 1100. 11100. Yeah, 11. It's written here negative 1110. And then the denominator is 4. Then G2 is from here, X2. So this is X2, and you put this one as 1110. Subtract by same number 1110. That is actually 0. Okay. So technically our answer P, that one equals to P of Z value negative 2.5 and then less than 0. So it is P of Z equals 0 minus P of Z equals to negative, yeah, this way, negative 2.5. All right. So let me just clarify it. So far we didn't do anything very special. We just calculate or converted X value to Z score. Okay, so what is this value? Can anybody guess the value of this without using the table again? Excellent engineers you know the answer without calculating it. So what do you expect? What would be the kind of value close to this real answer? Any guess? 0.5? Little more. It's more than 0.5 or less than 0.5? Yeah, the answer is almost correct. So is it like a little bit less than 0.5 or a little more than 0.5? Yeah, so again, you could just plot it seemingly. So you have Z and then 0, and then you have this one. So this guy is just left half. So it is 0.5. And then the second guy is somewhere here, negative 2.5. So this portion is very, very small. It is very, very small. I mean, after z-score negative 2, well, 2.5 is between 2 and 3, however, still very small. So that one is kind of small, but not equal to 0. So the real answer is 0.49370. Okay. So if you write your answer like this, what I just calculated, I think this is still like 90 points or not 100 points because I still cannot see well, I can see the procedure step by step, but I don't see the final answer. So your final answer should be like this. You need to write down the sentence, such as let me just write down. Hopefully it works. The probability um, for the average length of battery life um, between and 1110 days is 49.73%. Every time I use this technique, then I need to change the font size. All right, so this is actually the final statement, your answer that you actually need to write. if this is the kind of written exam, okay? And especially when you write your project report or proposal. Yeah, proposal is some explaining something that to you is of course thing and it's so easy and everybody knows, but actually customers are not. So proposal is let the audience, like public audience, understand what you are planning. So proposal should be easy reading, but should contain all the technical information. Okay, so rest of problem is just straightforward. And this one, again, if I write down the answer in different form, second problem B is asking what is a probability that X is greater than, oh, the other way. X is greater than X1. This X1 equals to 1120 less than what this upper limit is actually the infinity. Yeah. So you can just say that one equals to P of X greater than X1. That's it. Because your upper limit is infinity. Number C is the other one. So your lower limit is negative infinity, but your like upper limit is 900. Okay, so let's solve the next one. What time is? Okay, a moment. So I actually got the textbook um, last week. Again, but you don't need to purchase the textbook. If you want, you could. I'm not gonna block it, but well, it is kind of expensive. I'm actually the faculty senate for engineering in UH Manua. We actually discussed a lot about how we could reduce the textbook cost that you actually need to pay. One of them is just using some copies of from the multiple resources, or like me and I use the PowerPoint. PowerPoint include almost all, but book includes the complete set of information. So if you want, then you could purchase textbook, which is 15th edition. But technically, you don't need to. All right, so let's just do this. Spurs and Achilles tendon. Well, I had like big problem in January for this, and so this problem kind of get my attention. Yeah, you could actually read up to here quickly, 30 seconds. Good. So, just my voice is great. So variable is Achilles tendon diameter. So it is meaning the mean value is 5.97 millimeter. And then the standard deviation is 1.95 millimeter. Okay. So that's it. Yeah, that's kind of basic information that we have. How do they know? Well, we don't need to worry about it. Yeah, this is kind of given. First question is, what is the probability that the randomly selected sample of 31 patients? So you have 31 patients. Yeah, in January, I was one of these 31. I couldn't walk too much. Would produce an average diameter of 6.5. So your sample average is 6.5, again, the millimeter. And up to this point, you better write down the units. Then you will know that either you could just subtract or add. So probability that 31 patients would produce an average diameter of 6.5 millimeter or less. So A, the probability that X bar, sample bar, is 6.5 millimeter or less. Yeah, that is the case. Then what you need to do is convert this one into z-score. Z-score is again x minus mu divided by the sigma sample, the population standard deviation divided by square root of n, the sample mean, sample size. All right, so if you calculate it, x is 6.5, sky, and then your mu value is given as 5.97. Okay, this one. And then you have a sigma population standard deviation of 1.95. Yeah, if you just do up to here, then you are ignoring central limit theorem. So you actually need to divide this one by n. N is 31. So here your z-score, I believe, is 1.51329. Yep. Okay. And then let's see here. So we actually have upper one that equals to P of X bar. Yeah, here you could just say negative infinity or 0. So plug in this value. So it is equal to P of Z equals to 1.513. Okay. And then this probability is how much? Your Z-score is 1.13, and what would you expect the probability? Just lower equals Z. So will it be greater than 0? I mean, greater than 0.5? So this one, will it be greater than 0.5 or less than 0.5? Hmm? Don't make me lonely. So this value, will it be greater than 0.5 or less than 0.5? Greater than? Why? Why? Because your z value is positive. Yeah. So you are actually taking left half and then certain portion. Okay, so the answer is 0.93490. So you should write the answer is 93.49%. So try to use the four effective number in your answer. Yeah, probability is quite like sensitive in accuracy. So we gonna calculate everything having the 6 digit, and at the end the answer should include the four-digit number. Okay. So the rest of them is also kind of straightforward. Yeah, 27. Tossing coins. This is a proportion statistics. And again, that final answer will be requesting that you actually have P in terms of z-score, not this p. So this p is corresponding x in previous case. Then we actually have to convert this one into our own z-score. So technically, the first step is to calculate boundary of z. That is 0.44 will be certain number and 0.61 will be certain number. I would like say z1 caret and z2 caret as we did in X case. You can try to calculate these values, z1 and z2. So in the proportion statistics that you have P hat that is P bar, how do I say? P bar plus minus, oh no, what do I do? Your Z bar equals to P bar minus P, okay? And then you have sigma, and the sigma is um, n, similar to previous case, and then sigma divided by square root of n equals to P times Q divided by n, and then you take a square root. So your Z1 score will be, because P1 is 0.44, 0.44 minus P value is P, and then your denominator should be such as like P times Q divided by N, okay? Do we know N value? Do we know N? This one? Yeah, 80, good, thank you. Then you're kind of stuck, right? We know this Q equals to 1 minus P, but we still do not know the P value, right? What do we do? Hmm? So in the proportion statistics, then this is the equation that we're going to calculate z-score. And problem is quite simple, and we have a lower bound and an upper bound of z-score. To calculate them, we need to know n and p. But we know n, but we don't know p. What do we do? I got one response, and any other thought? How do we determine p? I'm waiting one more or a few more responses from you. Um, the method to determine P, yeah, I should use determine, not estimate, not assume. Determine P is, well, in all the problem used to test you, the answer is already in the problem. Otherwise, the problem wouldn't be given to you, at least before you graduate. Yeah, and outside of the academia, then sometimes you don't have enough condition to get your answer. But in this case, the answer to my question, what is p-value? It is embedded in the problem. Tossing coins, but we are not tossing just arbitrary coins. We are tossing fair coins. Yeah. Fair coins. Coin has head and tail. Fair coin means probability of head is 50, and also the probability of tail is another 50%. Yeah, so we're just gonna put this P equals to 0.5. So your Z1 is X1 or P1 value 0.44 minus the mean value is 1/2, the p-value that we just determined. And this p1 is 0.44 square root of 0.5 as p-value, and then 0.5 as q-value, and then divide by how much? Divide by 0.5 times 0.5 divided by here, that is n, sample size, which is 80. Yep. That one becomes yeah, Z1, and then Z2 is same. So I'm just gonna go to the next slide because the rest of calculation is or equal. Okay. I like this one because I do the environmental engineering. However, um, I promise you that at the beginning of a class I'm going to confuse you. So let's just go ahead this one. Yeah, that one is actually the upper limit and lower limit. Here we have warning power. Yeah, so upper limit is UCL is X 2 bars that grant the mean, and plus 3 times S standard deviation divided by N, and then your lower central line is this one minus 3 times S standard deviation divided by square root of N. Okay, so we have X bar, which is this one. So you can just use 7.24 here. Okay, and then your S value is given at 0.07. So your S value here is given as 0.07. Okay, now um, I'm not gonna make this one as extra quiz. However, um, I want everybody calculate this one, S divided by square root of N. And everybody type this number. That will be attendance check today. Yeah, I can check the attendance based on your login, but yeah, I want everybody calculate this one and then type it in the chatting window. And that will be all for today. And for you to sleep better during the spring break, I'm not gonna assign any homework or any assignment. But if you are late, any of previous assignment, you could just do it and additionally submit. Yeah, spring break is for you to recover. If you really like, if you have a burning desire to study statistics during the spring break, you could look at the handout of next chapter, chapter 8. But I didn't assign any one. However, calculate this S over square root of N, type the value in the chatting window, and I'll give you the right answer. That will be all for today. We have like 2 to 3 minutes. Please go ahead and, okay. I got how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10, 11, 12. I need 10 more. 13. I see the answer. One of the answer is 0.1278, and another answer is 0.01278. There's no way you could have this 10 times difference. I believe most of you guys. Okay, let me write down the answer. And I believe not many people got the right answer. So here the answer is 0. Just gonna slow down a little bit to make you guys like a little bit nervous. Answer is 0.1212. Anybody got the right answer? It's not, it is not 0.127, 0.1212. Okay, I think almost everybody made a mistake. Why? What is your n value? N equals to? Hmm? N equals to? Can you guys write down the n value that you used? 30, this one, right? No, it is 3. Again, I told you n is a sample size and different thingy. And here, number 30 is k value. This is actually the frequency. They measured 30 times with 3 species, 3 kinds of the specimens. So n should be 3, then value is 0.1212. Okay? Yeah. So again, I confuse you to give you right understanding. And this is the quite important. Otherwise, you're just gonna make mistake. Then whichever value you see, then you just put it as n value. Actually, I did the same. But when I double check, oh, this is not the case. Okay, so here you have number given 3. So sample size, 3 of 3 types of core, right? But the measurement is actually the 3, so I should say n equals 3, k equals 30, so they have a 90 kind of a measurement that they could use to calculate x bar and s. However, this n should be square root of 3, different number of different specimens of core. All right, that's it. Thank you and have a great spring break. And I'll see you in the Tuesday after spring break. Thanks. Attendance link. I should. Oh yeah, I'll do it. Just a minute. Never mind. Yeah. Because once you log in, then I have a login information. I'll take it as attendance. Don't worry. Yeah. Thanks. Bye. Take care. Eat a lot, sleep a lot, and take a rest a lot. But you gotta be healthier than before. Okay, I'll see you in 2 weeks. Thanks. Thank you. Just gonna remove you guys because you're inactive. Ryan, I'm gonna kick you out. All right.